on finding zeros of polynomials. Let's now look at part C. So we flip to the back side, and part C asks us to find all the zeros. So let's look at example 5. First step when finding zeros is to make sure that we have all of the terms that are needed. So we find the largest degree, a to the 4th, and we need to make sure we have every degree less than a to the 4th. So I don't see an a to the 3rd term, so I need to add 0 a to the 3rd, but I do have an a squared term and an a and a constant. So now we want to take the coefficients of each of those terms. A to the 4th is 1, a to the 3rd is 0, a squared is negative 24, a is negative 12, and the constant is 35. Now we are given that both 5 and 1 are zeros. So let's choose one of those. It doesn't really matter which one. So let's pick the first one here and say let's use 5. So I put my 0 in the box in front. Now I bring down the first term, the 1, and then take 5 times 1 is 5. 0 plus 5 is 5. Multiplied by the box number, 5 times 5 is 25. Negative 24 plus 25 is 1. 5 times 1 is 5. Negative 12 plus 5 is negative 7. 5 times negative 7 is negative 35. 35 plus negative 35 is 0. That tells me that we did this correctly because we were told that 5 is a 0, and this just confirmed that. So the fact that I'm given another 0 means I already took out x minus 5, and so what I'm left with here is, or a minus 5. So what I'm left with is a to the 3rd plus 5a squared plus 1a minus 7. But I already have another 0 here, and this is already set up, and so I want to use those numbers with my next 0, with 1. And so I want to divide a minus 1 into this polynomial. So I already factored out a minus 5 from the original, and so what I'm left with should be a minus 1 times something else. So if we do synthetic division with the remaining part, not with the 0, that was the remainder. And so we're going to bring down the 1. 1 times 1 is 1. 5 times 1, sorry, 5 plus 1 is 6. 1 times 6 is 6. 1 plus 6 is 7. 1 times 7 is 7. Negative 7 plus 7 is 0. And so if you are given more than one 0, use synthetic division and just keep dividing each polynomial and then its result by those zeros. So we already found 5 and 1, and now we're left with, let's see, this was a to the 4th, so this is a to the 3rd, which leaves this as 1a squared. And then 6a, and 7 is the constant. And so this result, we then want to try and factor if we can, and if not, use quadratic formula. Before we do that, I just wanted to show the factored form that we have so far is we just saw that a squared plus 6a plus 7 is one of the factors. And that was multiplied by a minus 1, that was another factor, and a minus 5. And so if you multiply these three factors together, it will give you the original polynomial. So we need to break down the a squared plus 6a plus 7. Now it turns out that one does not factor. And we don't really know that until you actually go through the x game and you see that 1 times 7 is 7 and the middle term is 6. And the only numbers that multiply to get 7 are 1 and 7, or negative 1 and negative 7, and those do not add to get 6. So this one is not factorable, so we have to use quadratic formula. So here's our a value, b, and c. A equals 1, b equals 6, c equals 7. So quadratic formula, our variable in this equation was a, so we'll say a equals the opposite, scoot over here, the opposite of the b value, so the opposite of 6, plus or minus square root. B is 6 squared minus 4 times a, which is 1, times c, which is 7, all over 2 times the a value, which is 1. So negative 6 plus or minus square root. 6 squared is 36. 4 times 1 times 7 is 28, so I'm doing minus 28 over 2. 2 times 1 is 2. So negative 6 plus or minus 36 minus 28 is 8. So can 8 be divided by any of those perfect squares? The only one that is less than 8 is 4, and 4 does go into 8. So I want to separate this into negative 6 plus or minus square root of 4 times square root of 2. 4 times 2 gives us 8. So on to the last column here. So a equals negative 6 plus or minus the square root of 4 is 2, and I can't do anything with square root of 2 over 2. So I look at the three numbers outside of the square root, 6, 2, and 2. Can those all be divided by the same thing? They can all be divided by 2. The bottom, 2 divided by 2 is 1, so the denominator will disappear. And I'm left with negative 6 divided by 2 is negative 3. 2 divided by 2 is 1, so 1 times square root of 2 is just square root of 2. So the zeros in this polynomial are 5 and 1, because those were given to us. And now we have negative 3 plus square root of 2 and negative 3 minus square root of 2. If you want to write it as negative 3 plus or minus square root of 2, that is fine. So there are our 4 zeros, which is what we expected since this was an a to the 4th power polynomial, degree 4. Alright, it is your turn to do the last problem for the you try. Good luck.